All right, welcome to another Technically You podcast. Today, we're looking at this thing called L4S technology, and it stands for low
Latency, low loss, scalable throughput.
scalable throughput. Yeah,
That's a mouthful.
it is a mouthful, but it could be a pretty big deal. And to learn more about it, we did some digging and found several articles for this topic. One that we pulled a lot of information from is called Decoding L4S Technology, the Future of Low Latency Internet.
Yes, it contains some good information.
And I guess our mission here is to kind of, to figure out what is this and why should we care?
Yeah, that is what they pay us for. Like, how could L4S technology change our digital lives?
Yeah, exactly. So, what is this thing?
So at a high level, it's all about improving the speed, the reliability, and the efficiency of internet traffic. And making this improvement is especially important for things like gaming and video calls. Anything real time where lag can be a major issue.
Yeah, you don't want to lag when you're trying to, play a game, especially right after you respawn. Haha. Nor do you want to experience lag when you are talking to your doctor or someone else important.
Exactly.
So, you mentioned the speed and the reliability. What about this buffer bloat thing mentioned in the article?
Okay, so buffer bloat, that's the annoying delay that we all experience, like buffering frozen video calls or the circling white circle we see on phone or computer screens. Buffer bloat is a critical issue in network communication, characterized by excessive latency and jitter due to overfilled buffers in routers and switches.
Yeah.
L4S wants to get rid of that.
Oh, the would it be nice?
Yeah. It's not just about downloading things quicker, it's about making everything feel real time,
Oh, I got it.
like you're actually there.
Okay, so no more waiting for that little spinning wheel of death.
Exactly.
Okay, so how does that actually work?
All right, so at the heart of it is something called active queue management, or AQM. Now imagine data packets traveling along your internet connection. AQM is like a super smart traffic cop, making sure those packets flow smoothly and efficiently.
Okay, so it's smarter routing.
Yeah, you could think of it that way.
But how does that actually make things faster in the real world?
So let's take video calls as an example.
Okay.
Currently, if your connection gets congested, the video stream starts buffering.
Right.
But with L4S and its AQM, it can actually tell the video call application to slow down its data sending rate just enough to prevent that congestion, so you avoid the buffering altogether.
Oh, so it's more dynamic than what we have now. It's not just like send the data as fast as possible. Instead, it's like send it at the right speed so that it doesn't get all jammed up.
Exactly. L4S allows applications and network bottlenecks to actually talk to each other in real time. And this back and forth communication leads to fewer interruptions and a much smoother experience for you.
So this sounds like they could really change everything about how we use the internet.
Well, maybe not everything, but it definitely has the potential to transform how we experience these real-time applications like gaming, video conferencing, even things like telemedicine could become incredibly reliable.
So imagine a surgeon doing surgery remotely and there's absolutely no lag.
Exactly. Or think about self-dreaming cars,
Okay.
communicating with each other seamlessly to make things safer and more efficient.
Wow. Yeah, I didn't even consider those applications. So it sounds like this could really be a key part of making all these futuristic technologies we hear about actually work more efficiently.
Absolutely. And the best part is it's designed to work across all sorts of internet traffic: TCP, QUIC, UDP, and RTP. It's all compatible. By the way, if you haven't heard of QUIC, it is a UDP-based stream multiplexing encrypted transport protocol.
So where's this now? Is it something that I can start using today?
So it's already being used in some of our internet infrastructure, L4S has already been adopted by cable broadband networks and is supported in the DOCSIS cable modem protocol, and it's in development for 5G and Wi-Fi.
Oh, wow.
In fact, Apple has already incorporated L4S support in iOS 16 and above and MacBooks Ventura.
Oh, so Apple's already on board with this. But doesn't Apple kind of have a reputation of doing their own thing with technology?
Yeah, that's true.
Could that create problems down the line?
It's possible that their implementation might differ from the standard,
Yeah.
and it lead to some unforeseen challenges.
Okay, so there's going to be some growing pains.
Yeah, probably, but MSO, multiple system operators, can deploy L4S across their whole infrastructure, thus improving services for their customers.
So, what are some of the other challenges that we're going to have to overcome?
Well, one of the big ones is legacy equipment.
Okay.
Older routers and networking hardware may need upgrades to support L4S.
Okay.
Some might just need firmware updates, but others might need to be replaced entirely.
And not everyone's going to want to run out and buy a new router.
Exactly. It's going to take time for L4S to really reach everyone's homes.
Yeah, and it'll probably be expensive.
Probably.
So, are there any other challenges besides the hardware?
Well, we also need to figure out how to distinguish L4S traffic from older internet traffic. We need smarter algorithms that can correctly identify and prioritize the different types of data.
Okay, so we need to be able to tell the old stuff from the new stuff.
Exactly.
So it sounds like it's not just about technology, it's also about getting everyone on board, making sure it all works together.
You got it. It's a big undertaking, but the potential benefits are huge. If L4S can deliver on its promises of a faster, smoother, more reliable internet, it could fundamentally change how we use the
So it sounds like something that we should all be paying attention to.
Absolutely.
So what do you think, listeners? If L4S takes off one, what parts of your digital life would benefit the most? How might a low latency internet change the way you work, play, and connect? Think about it and leave a comment. We'll catch you on the next podcast.